Welcome back. Let's continue with our index laws. Here's the link to part 1 if you missed it. What if we take the power of a power? You'll see brackets in situations like this. We have a squared cubed. If we expand, it looks like this. We get a to the power of 6. Put simply, if you have a to the power of m, all to the power of n, you get a to the power of m, n. You multiply the powers. There are also a few extensions of this. These are just as important. Here's a few quick examples. 3 to the power of 4 to the power of 5 is 3 to the power of 20. Multiply the powers. 2x squared, all to the power of 3, is 2 to the power of 3 times x to the power of 6, which is 8x to the power of 6. Don't forget about the 2. 2 is 2 to the power of 1. We need to multiply the power of 1 by the 3. 3c cubed on 4d squared, all squared, is 9c to the power of 6 on 16d to the power of 4. How about negative powers? Yes, they exist, and they're very important because as you learn further maths, you begin to use them more and more. We can use what we know about indices to understand negative powers. Take a squared on a cubed, for example. Using our index law, we take away the powers. So this is equivalent to a to the power of negative 1. If we expand this, look how we get 1 on a. So we can see that a to the power of negative 1 is equal to 1 on a. We encourage you to experiment with your own examples to develop a better understanding and see the connections between different laws. This is useful for understanding more abstract concepts like this. So for negative powers, we have a to the negative 1 equals 1 on a. And for any negative power, we have a to the power of negative n equals 1 on a to the n. If the negative power is in the denominator, we get 1 on a to the power of negative 1 equals a, and 1 over a to the power of negative n equals a to the power of n. Here's a few quick examples. 5 to the negative 1 equals 1 on 5. 2 to the power of negative 2 equals 1 on 2 to the 2, which is 1 over 4. X to the negative 3 over 3 to the negative 1 times y to the negative 2 equals 3y squared over x cubed. Last but not least, let's take a look at fractional powers. Again, let's use what we know to understand this. Let's start with a, which is a to the power of 1. Now this can be written as a to the power of 1/2 times a to the power of 1/2, because we know that half plus half is 1. A can also be written as root a squared, because if we square a square root, they undo each other. This is the same as root a times root a. So this means that a to the power of 1/2 must be the same as root a. Again, a bit more abstract, but isn't maths cool? So we have a to the power of 1/2 equals the square root of a. If we have a to the power of 1 on n, we get the nth root of a. And if we have a to the power of m over n, then this is the same as a to the power of 1 over n, all to the power of m, which is the nth root of a to the power of m. Here are a few quick examples. 9 to the power of 1/2 is root 9, which is 3. 8 to the power of 1/3 is the cube root of 8, which means what number multiplied by itself 3 times is 8? It's 2. 25 to the power of 3 on 2 is root 25 cubed, which is 5 cubed, which is 125. While it's fresh, now is the perfect time for you to put this into practice. We've put answers in the description. Don't wait until later. The only way to learn maths is to do maths. That concludes our lesson on index laws. Thanks so much for watching. If you found this helpful, we would love it if you left a like and subscribe. We make new videos all the time. See you next time.